My name is Mick Reynolds, Senior ISD Application Engineer with Imaginet Technologies. Today I'm going to be giving an overview of the Storm and Sanitary Analysis and the River and Flood Analysis tool for 2014. We'll also look at another Civil 3D hydrology tool. Before starting our work in the Storm and Sanitary Analysis, or the SSA for short, we're going to look at Civil 3D first to see the kind of items that we can export from the Civil 3D environment to the SSA environment. We're also going to look at some surface analysis styles that help us delineate basins, and in addition to that, yield our stage storage curves for our ponds. The first surface style we'll look at is a slope arrow style that places an arrow in the downhill direction on every triangle in our tin surface. By reading our contours, we can then delineate our basins. Another analysis type that can help us is a user-defined contour analysis. We can place contours at specific elevations, like a high water elevation in a pond, so that they're easier to see in our drawings. We can then use the stage storage utility to calculate the volume of this pond. And the stage storage curve can then be saved to populate the storage node in the SSA. The basin delineations that we've determined from the surface style using the slope arrows can then be converted into parcels. These parcels can be exported to an XML format and repopulated into the SSA, therefore bringing in not only the shape but also the areas, so the user doesn't have to populate these a second time. And the last type of export that we can do from Civil 3D are exporting the pipe networks themselves. Once we've exported all those items from Civil 3D, we can then come into the Storm and Sanitary Analysis and start aggregating our model from the import. You can see here in this picture I've imported my layer manager of a DWG file, which gives you some perspective on your site. I've brought in the land XML file for the parcels that delineate the basins represented in blue on this screen. In addition to that, I brought in the pipe networks using the Hydroflow storm sewer export that I just showed. We can set project options to determine the hydrology method and the time of concentration method used for this analysis. And based on our analysis type, we could either create a rain gauge or an IDF curve to define our storm event. We can then fill in information to help determine the flow from our subbasins by defining the sheet flow, shallow concentrated flow, and then channelized flow, therefore generating a time of concentration report, and also creating a weighted curve number for our site. The user can then further define their drainage design intent by finishing out the design and adding in a storage node. In this case, we can bring in the Civil 3D stage storage curve that we exported. We can add in and configure emergency overflow weirs by defining the size and the dimensions. And lastly, we can go ahead and define the orifices or the releases from our pond structures. We can perform our analysis for rain events and review the results of the analysis. One of the outputs that we can review are the profile plots of our storm lines. And we can even run output animations to show our pipe and how it drains during a storm event. The HGL and EGL information are created in our profile plot, and when we export our storm sewer network back into Civil 3D, it will not only update the pipe size changes that we determine we need through this analysis, but it also brings back this metadata and is populated into the profile views. Time series plots can also be produced so that we can get graphical data that we can then include in our reporting. As an output, we can also create custom reports by including and rearranging our sections to suit our needs. When the metadata is brought back from the SSA, re-importing the revised storm sewer networks back into Civil 3D will not only change the pipe sizes, but also the labels. In addition to that, when we look at the profiles, we'll also notice that it brings back in the metadata such as the HGL and the EGL information. Besides the Storm and Sanitary Analysis program, Civil 3D also has another tool that's incredibly useful called Hydroflow Express. The Hydroflow Express is a hydrology calculator where it can perform calculations on things like culverts, channels of many different shapes, inlets. We can perform hydrographs and also perform weir calculations. Performing a hydraulic calculation for things such as a trapezoidal channel, we notice that not only do we get nice graphical results, but below we also get incremental results, so we make sure we size our hydraulic structures correctly. We can also run reports of our hydraulic calculations to include in our agency submittals. The last hydrology tool we'll look at is the River and Flood Analysis. This module allows you to evaluate reaches in streams and rivers using HEC-RAS. The user can start by creating cross-sections and profiles of those cross-sections. We can define the overbank characteristics for each one of our cross-sections and also digitize the overbank locations in the plan view. Now that I have my reach created, I'm going to come over and go to my reaches option here, and I'm going to go ahead and tell it to create this as a reach. We'll go ahead and select OK. It tells it's already created, so we'll go ahead and we'll put in a different one here. We'll call it number 2. Now that we've actually named our reach, now we're going to go ahead and determine the flows that are actually going to be coming through here. So when we come up to our flows, we'll go ahead and select this. We can go ahead and add in a profile or a storm profile for each one of the storm events that we want to go ahead and do this for. I'm going to go ahead and just do a 10-year event here. So now what we need to do is we need to tie a downstream flow to this particular storm event. So we're going to go ahead and call this 300 CFS for this. When we're done, we'll go ahead and apply, and we'll go ahead and select OK. I'm going to go ahead and compute my analysis here. Once the analysis is complete, then we come over to the flood mapping. We're going to go ahead and add a flood map, and you'll notice that it goes ahead and it gives us the limits of the 10-year storm through this particular channel. Then we'll come back up and go through, and let's go ahead and configure now the second option here. Now when we go ahead and select this, now we're going to go ahead and get a limit of that area. So you can see that now we have both limits of our flooding for our 10-year and for our 50-year. We can also generate a HEC-RAS report by going to the output report file. So I can go ahead and select OK, and we can generate our HEC-RAS report. We can also update this information onto our section views. We can come up and go to our Add Section Results, and we'll select this. For each one of these, we can determine which information we want to show. And now you'll see when we look at our profiles that it includes this information, and if we again zoom into our profile locations, not only does it place these in here, but it also adds a legend based on the 10-year and 50-year labels that I just gave it. It includes the flow discharge rate, it includes the 10-year elevations, and also the 50-year elevations for each cross-section. Once we've performed all these calculations and we've generated the reports, now it's time to actually export the HEC-RAS to a HEC-RAS project so that we can import this into HEC-RAS and generate the reporting features that we need to submit this type of a project. Thank you for joining me for this overview of the Storm and Sanitary Analysis, the Hydroflow Express, and the River and Flood Analysis utilities in Civil 3D. For more information, visit imagineit.com or call 1-800-356-9050.